Let's use the direct substitution rule first to evaluate this limit and to see if that will work out. So we will start by using the limit rules to rewrite this limit. Limit of x squared as x approaches 0 times limit of this cosine function as x approaches 0. Then we may use the direct substitution rule since 0 to the power of 2 is still 0, so just 0. And then times cosine 1 over 0. Here's the problem. The fraction inside this parenthesis have the denominator equals 0, which we know that it could not be 0. It will be undefined. So we say this whole thing is undefined. And the limit of this cosine function does not exist. And you may say, why do we have to care about the second term? Right? The limit of this x squared is 0, and then 0 times anything will be 0. Why don't we say that the value is just a 0? The thing is that we gotta make sure that the both limit of the function exist. If one of them does not exist, then we can say the whole thing does not exist, right? But we have to solve this, to evaluate this limit. Do we have another method? Yes, we have another method called Squeeze Theorem. It says, suppose f of x less than g of x, and then less than h of x, these three functions. Then, if we can prove that these two functions equal, the limit of these two functions equal, so limit of f of x as x approaches a, and this a is any number, equals the limit of h of x as x approaches a equals to a certain value, then we may conclude that the function in the middle, the limit of g of x, equals L. And this L is the value that we want to figure out. So in this case, let's try to write this this limit in this form, right? So g of x in this case is this these two function. So f of x less than x squared cosine, and then less than h of x. Then, according to this formula, we want to prove that f of x, the limit of these two functions, equal. But right now, we don't have that two function yet. What we want to do is to figure out some inequalities, right? It's much more easier to split this middle function into two parts. Split it into x squared, and then cosine 1 over x. And then separately to find their boundary, their inequality. So we start from this x squared. The boundary, the known inequality will be 0 less than x squared, because any number you put the square, let's say negative 1, put the square, the result will always be the positive number, right? Or if you give you this 0 to the power of 2 is 0, right? So it will always be greater than or equal to 0. That's the boundary. And this cosine, the boundary, the known boundary is negative 1 and 1. If you forget, reminds you this cosine graph. Here's a 1, and here's negative 1. This is the boundary, and we usually graph like this. So since we found the boundary, what we want to do is to rewrite this two boundary that is similar or the same to this first inequality. And since the middle function, we're missing some parts, right? For this one, we're missing x squared. For this one, we're missing cosine function. So why don't we just times the missing part on both sides? This one is cosine function, and for this part is x squared. And then simplify 0 less than x squared cosine. And then this one is negative x squared less than this middle function, then less than x squared. Now, what you want to do is to pick the one that is really similar to this first inequality. And this one, it does not look similar, right? You just only have this one symbol, but we have this symbol right here. So we're going to pick this one. Now, what we want to do is to prove that the limit of these two functions equal. If they are equal, then we can say this middle function will equal to the value, same value. So the limit of negative x squared as x approaches 0, this x approaches 0 is according to the problem given, right? This x to the approaches 0. Just keep it consistent. Now, by using the direct substitution rule, it will be 0. And then for the second function, x squared, by using the direct substitution rule, it will be 0 as well. So they are equal. Since they are equal, we can conclude that the function in the middle if we take the limit of it, will also equals 0 as well. And this is the answer by using the squeeze theorem.